Hello again, Spartan fans. We are doing part 2 of lesson 10 today. What I want you to do is I want you to recall back to part 1 that we did yesterday, and I want you to remember that the domain of a function is the set of all possible what's for a function. Okay? I want you to think about that. Pause the video, give it some thought, and put an answer in here, right here, and then I'm going to put an answer next to it. Okay? And I want you to do the same for the one right below it. I want you to think about what the range of a function is. It's the set of all possible blank for a function. And I want you to have an answer circled right here, and then afterwards, I'm going to have my answer written right here and right here. Okay, so go ahead and pause the video, think about it for a couple minutes, and then write an answer in the circle. All right, now that you're back, I am going to give you the answer. For the domain of a function is the set of all possible inputs for a function. And then the range of function is the set of all possible outputs for a function. Also remember that sometimes, and we talked about this yesterday, sometimes you'll be told what the domain or range of a function is. More often, you'll have to figure it out for yourself, but here's an example of how we tell you what the domain of a function is. Okay? Right now, I got a function. It's called f of x. And the directions or the instructions that f of x gives me is I take x, I multiply it by 3, and then I add 1. Okay? But that's not the part that is the domain. The domain is right here. This is the domain, and it's telling me where x is between the values -3 and +3. Do we see that? So x is allowed to equal -3. X can equal -3. X can equal +3, and it can equal any number in between. It can equal 0. It can equal 1. It can equal 1.827496, yada, yada, yada. It can equal E, which you haven't gone over E yet, but you will in a couple of years. That's a lovely number. That's my favorite number right there. Anyhow, I digress. We're going to show you how to graph this function. First of all, we know how to graph this line right here. We know how to do it. What we don't know is how to incorporate this part, okay? So first, I want to consider this part. From -3 to 3, x is allowed to equal -3 to +3. So I'm going to change to calligraphy pen because I like calligraphy pen. Now, when it says x is allowed to equal anything between and including -3 and +3, here's how I'd like you to do it. I want you to put a dot on -3. Why a dot and not a circle? Do we remember what dots and circles are? Let me ask you this. If I did this, if I did that, what does it mean? You should remember that from earlier in this class. And it means that my number can be any value between -3 and +3, but it can't be -3 or +3. So the inequality that I would do for that is -3 less than x less than 3. But remember from up here, I got these underlines there. That means less than or equal to. And to show equal, I fill in those dots. I fill in those circles. Okay, so I've done that. Now, what that means to me is that my line is going to end, it's going to begin when x equals -3, and it's going to end when x equals +3. I'm sorry, it's going to begin when x equals -3. It's going to end when x equals +3. Now, we're going to build a chart. X and Y. Well, no, not Y. X and f of x. I'm going to stick in function notation. And I'm going to go -3, -2, -1. I want you guys writing this down. 0, 1, 2, 3. Okay? And I'm going to do, when x equals -3, so I plug in -3 into x. So f of -3 equals 3 times -3 plus 1. 3 times -3 equals -9 plus 1, and -9 plus 1 equals -8. So when x equals -3, f of x equals -8. And I'm going to graph that point in red. When x equals -3, when x equals -3, let's see, when x equals -3, f of x equals -8. So I'm going to put a dot right there. So let's do that. Right there. Good. And then I'm going to go all the way over to +3. So I'm going to erase this. Actually, no, I'm going to leave that there because your notes have it there. I'm going to do right here. F of +3 equals 3 times +3 plus 1. Now 3 times +3 equals 9, and I still got to add the 1, and 9 plus 1 is 10. So when x equals +3, f of x equals 10. So to graph that, I go over to x equals +3 right there, and then I go up to 10, and I put a dot right there. That's where I'm going to put my dot, except I'm going to put it in red. There you go. And I know this is a line. I know it's a line because this function looks like a line. I got my m, which is slope. I got my b, which is my y-intercept. So I have all the parts I need for a line. Okay, so now I'm just going to connect the dots in red. I don't want it that thick. I want it that thick. I'm going to start here, and I'm going to end right there. And I'm not going to go any further. Before, we used to put arrows on it to tell you that it went forever. But this one doesn't go forever. So we take those arrows off, and we just leave it like that. And then I want to label this. I want to label this f of x equals 3x plus 1. I'm going to get rid of that green line there. Boom. And then where x is between -3 and +3. And I label that. That way I don't confuse the red line with the green line and what they mean. Okay? So now that we've done that, I want you to go to the second page. I'm going to show you how we tell you the range of the function. I've used the same function. Notice I've used the same function. Okay? However, I've done something a little bit different here. In this space right here, I want you to tell me what's different about this one than the previous page. So pause the video, look at this, and look at the one on the previous page, and tell me what the difference is. And write it right here. Pause the video, Write that down, and then when you're ready, unpause it, and we'll go over it. Okay, now that you're back, you should notice that the difference is, in the first inequality, this was not f of x, it was x. Now it's f of x, which is telling you how high or low this can go. Now, here's what that means. So instead of telling you how far left or right we can go, we're going to tell you how far up and down you can go. So we're going to go, remember, f of x can get as high as positive 3. I'm going to put a dot there because, remember, it's less than or equal to, and then I'm going to put a dot on the bottom at negative 3 because it's less than or equal to. Okay? And I'm going to build my table again. I'm going to do x. I'm going to do f of x. And then I am going to do, let's do negative 1, 0, positive 1. Okay? So, I'm going to do f of negative 1 up here. And this is going to equal 3 times negative 1 plus 1, which equals, well, 3 times negative 1 is negative 3. I can't forget the plus 1, and that equals negative 2. Now, negative 2 is in my range. It is between negative 3 and positive 3, so I can put it down. I'm going to do it in red. Now remember, positive, negative 2. So I write negative 2 right there. I'm going to graph that point in red. Now that is negative 1, negative 2, right there. And it's between the green dots. So let's put that point there. Okay, now, when x is 0, I do f of 0 equals 3 times 0 plus 1, which equals 3 times 0 is 0 plus 1, which equals 1. There. That's also between negative 3 and positive 3. So at 0, f of x equals 1. So my line is, or my dot is right here. So that's what I'm going to do. I'm going to put a dot right there. And let's do positive 1. So f of positive 1 equals 3 times 1 plus 1, which equals 3 times 1 is 3, plus 1 gives me 4. And now I say, uh-oh. Why? Because 4 is bigger than 3. Remember, I'm allowed negative 3, I'm allowed negative 3, I'm allowed positive 3, and I'm allowed any point in between. But I can't do any point outside of that. So I'm going to write down 4 right here, but I'm not going to graph it. Okay? Luckily, I have enough points to draw a line. So I'm going to start right here. I'm going to go through there all the way till I get to the top of my range. I'm going to do the same thing with this one, all the way till I get to the bottom of my range. And there you got the line. And I'm going to put in my endpoints nice and dark so we don't think that I've gone past my range. But compare this graph to the graph on the first page. What's different about the two lines? What's different about the length? Is one longer than the other? Right here, I want you to write down what the difference between the line on the first page and on the second page is. When you've done writing that, unpause the video. Well, pause the video now. When you pause it, write down what the difference between the two lines are, and then unpause and come back on the next page. Now, this is really the meat of the lesson. Like I said earlier, sometimes I'll tell you what the domain and range of a function are, but what if we don't? What then? For example, if I just write down f of x equals 6 divided by 1 minus x, I would ask you, what is the domain of this function? Okay? Now, I've told you earlier, usually when you don't see anything written over here like a domain or a range, something like -3 less than or equal to x less than or equal to 3, right? If you don't see something like that over here, then you can usually assume that all numbers are part of the domain and range, but not always. So let's look at this one specifically. I'm telling you, this one does not have the domain of all numbers. Why is that? Well, when asked this question, it is sometimes better to ask what numbers cannot be in the domain. So let's try a few. So I'm going to write this answer down again. 6 divided by 1 over x. F of x equals 6 divided by 1 minus, no, that wasn't it. 6 divided by x minus 1. Okay, so now that I've written that down, I'm going to do f of -3. And that equals 6 divided by -3 minus 1, which is 6 over -4, which is -2/3. Okay, so f of -3 is -2/3. Okay, let's do f of -2. F of -2, that is 6 divided by -2 minus 1, which equals 6 divided by -3. And I can simplify that fraction too. That is -2. So when x equals 2, when x equals -2, f of x also equals -2. Now let's do f of -1. Now I replace every place where I got an x in that equation with -1. So the x was here, so I put -1 there, minus 1, and this equals 6 over -2. This 2 simplifies. It simplifies to -3. So when x equals -1, f of x equals -3. Now, let's do this one up here, f of 0. We're up here now. And so now I got 6 divided by 0 minus 1, which equals 6 over -1. And that simplifies as well. That's -6. Oh, yep. So when x equals 0, f of x equals -6. Now let's try x equals 1. I get 6 divided by 1 minus 1, which equals 6 divided by 0. And if I punch that into my calculator, what do I get? I get error. Why do I get an error? Because you can't divide by 0, right? Because you can't divide by 0. So why did x equals 0 not work? Why do you think? While you're thinking about that, pause the video and then come back with an answer. Okay? And then lastly, let's do x equals 2. So this would be 6 over 2 minus 1, which equals 6 divided by 1, which equals 6. So this can be an answer too. It's this one that trying to draw a mushroom cloud. It probably looks like a flower, but it's more like a nuclear explosion. We broke your calculator by trying to divide by 0. Okay? So we understand that the domain cannot include 0. Now, like I said, sometimes it's easier to ask what numbers cannot be in the domain. When I'm expressing the domain, I can also just show you that they cannot equal 1. When x equals 1, I break the equation. And what this means is that all other numbers work. Okay. Thank you for your time, ladies and gentlemen. Have a great weekend.